Yeah, I hope I am audible. Yeah, thanks. Thanks for acknowledgement. Okay, so let us start. So before moving to actual subject, let us try to understand some of the terminologies and like the flow of a program. So let us try to understand. So okay, so system dependent or platform dependent. So usually we will have multiple terminologies. So we need to adapt this, like we need to understand what exactly like system independent or platform independent is nothing but like a platform is nothing but platform meaning is nothing but a combination of platform is nothing but a combination of your operating system. Like operating system, we have a multiple like Windows, Mac, DOS, Unix, Linux, like multiple operating systems we have. Combination of operating system plus processor, microprocessor, microprocessor. So here system dependent, the name itself tells, right? Dependent. Dependent is nothing but, let's say if a programmer, yeah, if a program or application developed using a OS, okay, A operating system, and B microprocessor. Then that means then that program or application works only on that system or platform. Okay, platform. So what does it mean by system dependent? The name itself tells dependent. There is a dependency. Dependency means like, again, like a platform is nothing but like wherever, like whatever the applications we are building, like whatever the programs we are running, all these programs and applications, where are we running? Like either we are using our personal PC or laptop we are using, right? So desktop applications. So which means that the platform is nothing but a combination of operating system and microprocessor. So what does that mean by system dependent and platform dependent is nothing but, let us say, like if you have developed one program or any application, small application, okay, so using A operating system and B microprocessor. Okay, so it means that it program runs with that same configuration. That program will not work even if any small or minor change with the configuration. That is nothing but a system dependent. Okay, so in a sense, let us say now I have developed this program or application using Mac. I have written some program. Now I will share the same details. Okay, so just please execute the same program or application without changing anything. You can just copy, paste in other platform, other system. Like platform, when I say platform, you need to consider this is. Okay, so it will not give a consistent results, like a multiple, like sometimes it will give a compile time errors. So sometimes it will not recognize because of this platform dependent. So now come back to system independent. Independent, we know independent is nothing but platform independent. System independent or platform independent is same thing. Program or application developed using A operating system and B microprocessor, then that program or application works anywhere, irrespective of your configuration. irrespective of your configuration. So independent and dependent. Dependency is nothing but there are some dependency related with microprocessor and operating system. Independence is nothing but we don't have any dependency. In the sense, it will give a consistent and portable results. Portable result is nothing but if a program or application gives same result irrespective of your platform or irrespective of your configuration, then we can consider that as a system independent or platform independent. Why we are saying here is nothing but, so let us go. So now one query will come. Like when I say system dependent and system independent, now we'll say how Java is system independent. Independent when compared to C or C++ or C or C++ programming languages which are system dependent. Which are system dependent. Like how Java is so famous. So Java is famous. First reason is this one, system independent. Like why, how we can see now. So now the query is like how Java is system independent when compared to, so like when Java released it in the market, like earlier. So on that time, like C and C++ were the famous languages, like each and every application programs run on. In the sense, this programming language overcomes all the programming languages which are hot on the market, like earlier. Okay, so now we'll try to learn like how Java is system independent and why C or C++ programming language, which were very famous, now why it is not system independent. I mean system dependent, especially because it comes under an internet only, like network connection, internet, all these things we need to consider. Like when we talk about a platform or a system, it will consider all this information. Okay, so now let us see, let us try to understand like a C++ programming language, what are the flows basically. Okay, so now let me take one example here. So now let us consider any C program. Okay, any C program, what is a flow here? So let us run one sample, like just welcome to everyone. Okay, in C. Welcome to everyone. Good evening. Okay, so this is a C. Basically, what happens is like if you see, right, this is nothing but a main C. Okay, so whatever the file you are going to write in C, okay, in C language, the extension should be .c. Like each and every programming language will follow some notification, I mean extensions, so that we can consider and we can identify, okay, this file belongs to that programming language, or this program has written or developed using that programming language. By seeing that extension only, we can identify which programming language used to write a program or application. Okay, so now this is the extension we followed. Okay, this is the extension. Like in essence, like by seeing this, we can consider, okay, this is a basic program which we have written or developed using C programming language. So now what we are doing, we are just running. So my intention here is like write to print one message like welcome to everyone, just good morning. So this is like how we can, using a printf statement, we are going to print. So now you can just run this, it will give, okay, it gives some output, like whatever the output we have written, it gives. So the main intention here is like what happens here, like what is the flow? What is the flow of a C or C++ programming language? C or C++ programming language. Okay, so what is the flow? We can see now. So now if you see, like this is execution flow basically. So whenever you're writing any program, we have seen main.c. Like main.c is nothing but this is our source code. What does it mean by source code? Source code is nothing but like whatever the steps we have written in a human readable format. In the sense, if you see the above program, I have written like hash includes stdio.h, like int main. I'm able to read what I have written. In the sense, it is clearly understandable, like human readable language. That is nothing but a source code. Okay, So whatever the program, as I mentioned, like whatever the program you have written, extension should be important. By seeing this extension like .c, we can consider that this program is developed or written using C programming language. And we can call it this as a source code. What does that mean? Source code is nothing but a basic code you have written. So now what happens here, like, again, I'll just move back. So when I click on run, what happens internally is nothing but internally C compiler will come into the picture and compiles this program. Compiles this program is nothing but compiling like compiler. What is the job of a compiler? Compiler, what it will do, it will take the source code. In a sense, it will take your file or a program which you have written or developed. Okay, so it converts into machine language. In the sense, first, before going to machine language, it converts to object code. We can call it as a object code. Object code is equal to source code. Okay, so but we cannot convert, in a sense, C compiler directly not convert .c to .exe here. Okay, so what happens? First, it converts into object code. Object is having machine language instructions, which is equal to your source code. Okay, later, what happens? Like how you got the error here, like how you got the output, welcome to everyone, good morning or good evening, some message you're able to see as output. What happens here is like internally, C compiler will take your source code and convert into .exe file. First object file, after that internally executable file. .exe file, executable file. The name itself tells executable file. Executable file is nothing but system or platform will understand your executable file and gives the output. How it understands the executable file, we'll see that. What does it mean by executable file? What exactly executable file will contain? So executable file we will note as exe, executable file. Executable file. What does it mean by executable file and what exactly it contains is nothing but it contains machine language instructions. Okay, machine language instructions. What does it mean by machine language instructions here is which can be understandable by only machine, in the sense which can be like computer in the sense like how, what exactly contains, what is machine language instructions is nothing but like you can see like bits or I can say byte, which represents zeros and ones format, one format, like again, which is not in a human readable format, executable file, which can be only understandable by system. That is why machine language instructions. That is how you have written somewhere. Now you are going to change here. In any programming language, you are going to change here. Now I'll just give a learning first program. I'm just changing here again. I'm just changing the program. Now I'm running. So your system will understand what you are changing here. Now again, you see, every time output will change. How internally, in the sense like a C compiler plays a key role here. It's nothing but it takes your source code, which is a human readable format, okay, converts to machine language so that machine can understand your program and gives desired output. Like what is your input and what is your output, what you are expecting, system will understand based on the source code, what you have written in a programming statement, and it gives here. So yeah, right. So we got executable full. So now we have written one small program, now converted, like compiled that program, like a C compiler, what it do, like it understands your source code, like syntax error, everything, now converted to object code. This object code converts to executable file. So this executable file executed by system and it generates output, program output. That's what we are seeing, like two statements we have printed. So two output we got. So now what is the problem here is nothing but like, what is the problem here is like whatever the program you're writing here is nothing but like, I'll just get again like platform. I'll just take this. Okay, so combination of OS and microprocessor is nothing but like microprocessor will play a very crucial role whenever you're writing or developing any application. We have multiple companies we have. So basic, like a best example is like if you go with the Mac, we have a silicon processor. Like if you're going with an Intel, we have Intel, like AMD, like advanced micro devices, AMD, like Celeron, Spark processor, multiple like processors we have. Like even like when you want to purchase any desktop or laptop, any monitor kind of things, first we will check what is the operating system and what is a microprocessor. First we will check like whether it is a Intel processor, Celeron processor. In the sense, based on that, we will pick, right? The same thing. Let us take like platform. Now, what happens here is like each and every microprocessor company will follow some language instructions. Some it follows some format of instructions, like how they need to identify like whatever the human, like now I'm talking, like you are able to audible. Now I'm writing here. Now I'm writing, you're able to see like that. Now I'm executing one program. So now who is doing everything, all this activity, like so you're able to see the screen, you're able to like listen my voice, like you're able to see like I'm executing one program, I'm getting the expected output. Now I will just go to different articles here. So everything who is giving from backend, like how you are able to get all the details, like whatever, like I will just go and I will just search for e-commerce. So in a sense, like internet is a basic thing, but who is giving that information? Like let's say like Amazon and Flipkart and some e-commerce application, I'll go and I'll just open and I'll just show. We are able to see the content, right? See the content, items, description, price, everything. Who is giving from backend? Who is supporting? Who is supporting?
Processor OS.
Yeah, yeah. It's nothing but a platform. Okay. So why I'm saying is nothing but, so we are just discussing about like this one, like system dependent. So how is the system dependent? As I said, like each and every company, let us take three companies: Intel, Qualcomm, and Spark. Or we can take Cell. Okay, these are the three basic microprocessors which build microprocessor. So Intel follows one pattern as per their company process, like they will follow one pattern of microprocessor. Okay, so Qualcomm follows another pattern. Each and every company follows their own policies, process, rules and regulations based on the development. So follows their pattern. Okay, so now what we have did here is like we have executed one program while we are just discussing about this flow. Okay, program output. Let us say we have developed C or C++ program if using this one. Same program, if I'm going to use or application or program I have developed in Intel processor. Now I'm going to use the same application which is having a configuration of Qualcomm. It will not work. It will give error. Same Celeron also it will give, because let's say I'll just give, like even though you can take, like we are talking about a platform is nothing but, let us say in DOS and Unix or Linux, we have these are two operating systems. Platform is nothing but a combination of operating system plus microprocessor. In DOS, for example, if I want to add two numbers, so what is the command I need to write? Add a comma b. Okay, so in DOS, this is a format DOS operating system will support. Same way in Unix, if I want to add two numbers, how I need to write? A add b. This is how. In the sense, each operating result will come finally, like add 2 plus 3, 5. Like A add B, 2 add 3, 5. Final result will be same. But you need to understand like how they are identifying, in the sense how they are implementing the pattern, in the sense like each company, each platform will follow one pattern. So like C and C++, what happens earlier is nothing but like why we are calling as a system dependent here is nothing but, so whatever the application you have developed using X operating system and Y microprocessor, if you are trying to implement or if you are trying to use the same application in A operating system and B microprocessor, results will not come. Especially when you're talking about a distributed application. Distributed applications is nothing but the application which runs only on internet. That is nothing but a distributed, we can say, over network, in the sense like I need an internet to execute the program and all. So that's why, because we don't have any mechanism here. So I have written one program, I'm trying to compile and I'm trying to execute, because in my PC, I have this microprocessor, this platform, and my colleagues or some other one using this platform. In the sense, Windows with Qualcomm, Celeron with Unix, Intel with Mac. This is a major drawback of C or C++. That's why we can call it as a system dependent. System dependent is nothing but, what does it mean by system dependent? Like, but system dependent is like if a program or application developed using some operating system or some platform, then the same program or application works only on that particular platform, which follows the standard machine language instructions. That's why we can call it as a system dependent. That is a major drawback. So if you consider like 2000 and before, early 2000, like 1990, between the period of 1995 and 2000, internet vast, in the sense like more applications are started building over the internet. Earlier it was offline, but once internet, that network and distributed applications sharing from one system or one peer, we can call like one system to another system. So in that case, so this was the drawback. So what happens now? Now, what is the programming language to overcome this? So Sun Microsystems. I'll just explain about the history in upcoming classes. But only the thing is, like a Sun Microsystems is one company which identifies all the programming languages. In a sense, they have started one project. They need one project basically. They got one project to work on to handle remote control or micro devices. One kind of a project they got. They identified all the famous and working programming languages on the time. In the sense, they need to build a project. They need to identify. They have identified all the programming language. They have seen what is the pros and cons, everything. Later, they come up with this programming language. I will just explain like how Java came into the picture, like who is exactly developed Java, in the sense like who is the team behind that. In upcoming classes, I will say, but we'll just discuss about like how Java become system independent, overcoming the problem of other programming languages. In the sense like Java, like we can call it as a Java. For now, what you can consider is that Java is only a programming language like other programming languages. Like C, C++ is a programming language. You can consider Java is one programming language. Okay. So now, what is the flow here? Now, let me just go back here. Now, if you see, what is the flow? Just compare here, like a source code, object code, executable code, program output. This is a basic flow of any programming language before Java. Now, Java, what is this? Like, again, as I said, like whatever the file you are going to write, whatever the program or application, anything you can go into write, what is the extension we need to follow? We need to follow .java. Like whether it's a complex program, simple program, like whatever the program you are going to write, if you are implementing that in using Java, you need to follow the extension .java. Okay, so now again, like you have built one Java. Now what happens here is, okay, let us write in Java also one simple program. Okay, so now, for now, you can consider only just programming language. I'm just giving the history behind that. Okay, so I'll just explain all these things. You can just focus on the basic concepts here. Okay, so now what happens here is close. Now I'm just trying to write a simple program in Java. Okay. So let's wish everyone. Now I'm just writing a Java class. Wish everyone. Wish everyone. Okay. So now when I say wish everyone, so you go like wish everyone, this is a class. Okay. So desktop workspace sample. Okay. Thank you for joining today. Okay. So now we'll just go to this workspace, like what is the format it has saved. So desktop, my workspace and sample. Okay. Sample. So now you go here, source. Source is nothing but the programs which we are writing that is in human readable format. Okay. So now source, you see, right? So whatever the flow, we have a couple of files, but we have created this one like first one.java. Okay. First one.java. So wishing everyone, all these are .java files. Like when I create a new program or a new file, by default from ID by default, it will take as a .java file. Now what we are trying to do here is, so now let me just go back here. Okay, now we are in source. Okay, so now I'm just trying to, now you see, right? Now you just see, we are just trying to execute this program now with this flow, by following this flow. So now okay, so now what I'm trying to do, Java C is nothing but Java compiler. I'm compiling the program. I'm compiling. This is the second step. First step is I've written one .java file, which is nothing but a source code or a source file. Now let us compile this program. Okay, so let us compile this program. You got one file here, you see, right? Wish everyone .class. Now you go back here. So you see, right? Wish everyone .class. What does it mean? What does it mean? Before coming here, let us try to understand the flow here. Okay, so yeah. So now we have written one program, first.java, which is nothing but a source code. Now, when we compile, like using a Java C, that is a tool, like when you install automatically, Java team will give inbuilt files. Like a Java C is nothing but you are compiling a program, Java compiler. You are compiling a program. So what happens here is like a first.java, when you compile, it will convert it to first.class. What does it mean? What does it mean by first.class? Okay. So now you go back here. Okay, .java. After that, .class. Okay, so this is having a source code, like which can understandable or which can be human readable format. So this .class contains machine language instructions. Let me try to open in IDE. So what exactly after this compiling, you see, right? You see what happens here. So this is a .class. This is a .class file. So now it is giving source code recreated from .class file by IDE. Okay, that is fine. So what happens here is like this we can able to readable, but this is nothing but if you observe, like this is .java, this is .class. Now, what exactly .class is having? .class file is having a bytecode instructions. As I say, like byte is nothing but 8 bits. 8 bits. We can call it as a 1 byte is nothing but bytecode. Okay. So now you go to that flow. Now this is bytecode instruction. So when you compile .java file, it converts into bytecode instructions. Now, what is it? Bytecode instructions is nothing but bytecode instructions. We can call it as a bytecode is nothing but like which can be used to which can be used to represent your source code in machine language instructions, usually like bits and bytes, zeros and ones. As I said, like 1 byte equal to 8 bytes, 8 bytes. But this byte code will not understandable by, or this byte code, whatever the byte code instructions we generated with the dot class, this will not understand all these processors, all these processors. This bytecode instructions is only for Java. Okay. Whatever the bytecode instructions dot class files, these processors will not understand. Then who is for, like, what is for bytecode instructions is nothing but JavaSoft people identified the issue with other programming languages. If you see C++, compiler compiles directly and gives executable file, which can be used by microprocessor, or which can be used by your platform and generates the result if it follows the standard machine instructions. Like if follows A and B, this machine microprocessor follows A and B, and you have developed your program by using A and B format only, then it works. Here it will not work because there are some set of instructions. They have identified all these issues. What they have did here is nothing but they have introduced bytecode instructions. Whatever the program you write, after you compile, they have around 200 instructions which will rewrite everything, which will rewrite your source code. Like to whom we are giving bytecode instructions is, now you go. This comes into the picture. JVM, Java Virtual Machine, is nothing but to whom bytecode instructions is nothing but bytecode instructions is for JVM. What is the role of JVM? Java Virtual Machines. Bytecode instructions is for JVM. Now you go back here. Before giving any program output, what is the role of JVM? So now you just understand like three formats we have just explained. .java compiles the code, it generates dot class file, bytecode instructions. So this bytecode instructions is for JVM, not for microprocessor. Okay, this bytecode instructions is for Java virtual machine. What happens here? What is the role of JVM? So now what is the role of JVM is takes bytecode instructions, and converts it to machine language instructions. Okay, so this bytecode instructions is for JVM, and like this machine language instructions is for platform. When I say platform, it's nothing but a combination of your operating system and microprocessor. Now, how JVM exactly work, in the sense like how we can call it as a system independent, like where you write Java in one platform, execute everywhere, that we can call it as a portability. Portability is nothing but if the result is giving irrespective of the platform, in the sense if the same result is giving in multiple environments or multiple platform, then we can call it as a platform independent or system independent. How it will happen is nothing but, so once you install Java in any machine, so you have written a program using this configuration, like Mac and Intel, or Mac or Apple Silicon. There is one more process, Silicon. You install a Java and you have written one program. What happens here is like once Java compiler compiles that program and it gives dot class file which has bytecode instructions. These bytecode instructions will take JVM and converts to the platform understandable format. In the sense, takes bytecode instructions and converts into machine language instructions. It means that now you're running in Intel. So what happens? JVM understand Intel processor steps or process. Now converts bytecode instructions according to Intel processor. So no issue here, because Because what is the role of JVM? JVM is a program which can be used to convert bytecode instructions to machine language instructions, which is supported by Intel processor. So you're executing a program. Program gives now portable, and platform independent. It means that internally, this acting as a mediator between your source code and program output. How the platform is executed in multiple environments here is like this JVM. JVM plays a very key role in this system independent. Now we can take one more processor here. Now we can take silicon processor or Celeron processor. We can take Celeron processor. You have developed same program. Now what happens here? Now JVM will come into the picture, because like once you compile your program, so it generates bytecode instructions. That bytecode instructions JVM will take and converts into platform understandable micro language instructions. Okay, so now understand Celeron processor. Celeron process steps convert bytecode instructions according to the format which is supported by Celeron processor. So no issue here. Portable and PA. Same way, Linux you can take. Linux OS, it follows some commands. What happens again? JVM is a mediator which can be take bytecode instructions accordingly and converts to each and every microprocessor, so that everywhere your program will work without any issues. That is nothing but we can call, this is one of the future introduced by Java, is nothing but a portability. Portability is nothing but if a same program gives same result irrespective of your platform details. That is nothing but a portability. This is a basic and important feature of Java. Okay, so now let us go to our code. So we generated .class file. Now what we are doing here, we compiled, so it generated .class file. So now what we are trying to do, we are converting this .class file. To machine language instructions, so that machine can understand your source code, executes that, so that whatever the output you are expected, it should give. That is the expectation. So now take your bytecode instructions, now convert into machine language instructions. Now we are doing the same thing here. Wish everyone. So now machine language instructions are there with system. Now you hit this. Now what happens here? Thank you for joining today. Okay, so now you go back here with the flow. So now what happens here? We have written one Java file, which is nothing but a source code, human readable format. Now compiled using Java C. Java C is nothing but a compiler, Java compiler, which has bytecode instructions. Okay, so now these bytecode instructions is for whom? Bytecode instructions is for not for a platform or not for a microprocessor or not for OS. Bytecode instructions is purely for JVM, because JVM only understands these bytecode instructions. By considering other programming languages drawbacks or cons, JavaSoft team has designed separately this Java virtual machine, so that it will take whatever the .class file generates bytecode instructions, it converts bytecode to machine code, so that machine, in the sense like a platform, will identify or platform will understand only machine language instructions, which is in a form of bytes, like bits and bytes, like zeros and ones. Machine will understand only in a form of 0 and 1 only. Okay, so we need to make system to understand what I have written, like what I have developed, whether that is a small program or application. Finally, machine should understand. So what happens here is JVM will come to the picture. It takes bytecode instructions, converts to machine code. So now what happens here is, like, once it converts to machine code, when you run the program again, machine will understand and it gives your program output. That's what we have seen here. We compiled a program, .class file is generated. Now we run the program. So what happens internally with this command? bytecode instructions converted to machine language instructions so that machine understands what you have written here exactly. Now, what you have written so that what is your expected? Our expectation is it should print as an output. It is giving this output. This is the flow. This is a basic flow of a programming language, why it overcomes dependency from other programming languages and why Java is so become a popular. Two things why became popular. First thing is due to platform independence. Second thing is portability. Okay. So for now, what you can do, what you can understand is like Java is a simple programming language. Java is a simple programming language as other programming languages available in the market. In upcoming sessions, I will just explain like what is the history behind that, like why it came. We know now we know like why it came basically, but what is the intention? What is the intention? Like what is the project? Like what is the reason behind that? So that JavaSoft or Sun Microsystem, instead of using other programming languages, why they have invest more, in the sense like why they have invested more on developing a new programming language. We'll see in tomorrow's session, like what is the history behind that, like what are the futures available in that. Okay, so I'm stopping the session. So yeah, we can take it up. If you have any queries, yeah, we can take it up.
So as you said, system independent, like it varies with the OS as well, or just
Yeah. No. System independent is nothing but it comes as a platform. That's why I have written system independent
Yes.
plus platform independence. System platform is nothing but a combination of OS plus microprocessor. Is nothing but like you can just take a laptop example. Okay, so how it works, like without OS, microprocessor, it will not work. Like again, I have a OS, but I don't have any microprocessor. Like I have Windows, but no microprocessor as inbuilt. So it's a combination platform.
Okay. Got it. So one question, like how these applications vary, some doesn't run in Safari and some do run in Chrome. Like, have any relation with this?
Browser is nothing but a web client. Is nothing but like again, like a browser will work only with the URL. In the sense like
Okay.
let's say let's take like that is a web client, we can call it as a, that is a separate topic, but I can just highlight that browsers. Again, it depends upon web browser also configured with the platform only. So if you say like we have a two browsers, let's say, so basic browsers like Mozilla Firefox and Google Chrome, these are the two
Yeah.
browsers. Again, browser, like when you open browser and take any e-commerce site like a Myntra or Amazon, when you type the endpoint or URL, it redirects to that particular site and it gives you the details, right? So again, it works two things here. Like one is your platform should support, so that browser will launch. It allows you to endpoint, I mean, to type the endpoint. Again, based on your network or internet, it gives. Like you can consider this, all these, if everything works, then only you can able to see the items available there.
Yeah. Okay.
Again, it's a part of the like a
It's like a
web browser.
combination.
Yeah, it's a common. We can call it's application part of the platform.
Okay, got it. Yeah, that's what I was a bit confused. Like, I just want to understand like
Yeah.
how gets related. Yeah, because
Ah,
since you have mentioned, right, it's an OS, so I had
yeah.
this question.
No, you need to consider. Yeah, that's what like OS is nothing but like as a separate concept I have taken, but you can consider this as a platform. Platform is nothing but a
Oh,
combination of OS, microprocessor, like whatever the basic stuff I need to work.
okay. Yeah.
Any other queries? So first 5 sessions, like till like this is a first 4 or 5 days, it's like a more on interactive session with actual subject. Like most probably like a 40 minutes, I'll take one session. After that, like if you have any queries, so we can take it up. So from next week onwards, I mean like this is like this one, like interactive plus I'll just explain one concept. So we'll share assignment and hands-on applications and all. So you can do like whenever you have time and all. The expectation from you here is like if you're learning any programming language, right? Okay, so if you are learning any programming language, you need to put effort, like at least a 60% effort you need to put. In the sense, like at least you need to do hands-on, then only any programming language it will come. So even that's fine. Like even if you get initial way, like those who don't have any subject knowledge, in the sense those who are new to this programming language, that's fine. Like if you have any issues, exceptions, so we have email ID. So I will guide like why that is exception is coming. Like I'll just make you understand how we need to resolve that exception, whether that is a compile time exception, a runtime exception, or any syntax exception. Like, are we missing anything in there? Okay, so one query I got. I still don't understand the platform independent. Okay. Yes, yes. Java uses JVM inbuilt, in the sense like when you install Java. Okay, so there is a separate hierarchy. There is a separate concept of a JVM architecture. How your program, when you write source code, right? When you write any source code, like how your program, like what is the mechanism behind that? There is a separate architecture for that. Just hold on for 1 or 2 more sessions. I'll just explain like what is JVM. So why JVM? What is the need of JVM here? What is the role? What is the role we know now? Now what is the role of JVM? Is nothing but whatever the program you have written in Java, JVM will take that program and converts into machine language instructions. Okay, so without JVM, yes, without JVM, we cannot run any program because JVM is a heart of the Java program, we can say. Okay.
Okay, yeah.
I'll just explain, like we can just go by the step by step. First, we have learned like how Java become so popular, in the sense like what is system independence. In tomorrow's session, we'll see like exactly what is the need to come or to develop Java. What is the need, like a JavaSoft team or Sun Microsystem? What is the need? Java, they need to get the Java. So after that, like what are the futures? And like again, like what is the architecture we followed, like what is the, now we have seen one sample example. So I compiled whatever the program I have written. After that, I have executed, we got one result. Exactly how this mechanism works internally. We'll show the architecture, right?
So, Mahbub, I think yesterday I've missed the session. This session I haven't joined. So, it was all about the introduction, right?
Yeah, yeah.
That
It's
nothing
all
much
about the
technical
introduction.
that you have.
Introduction is nothing but like related with the course concepts. What are the course? What is the duration? What are the timings every day?
Okay.
So yeah.
So are we gonna know about these versions as well?
Yeah,
Because
versions is nothing but like futures. We'll
yeah.
just explain futures like uh, I can say like what is the difference between multiple versions. Now we have Java 20. Okay,
Yep.
Java stable version is Java 2021. So to reach 21, so what is the current future? Like how flexible they have, how flexibility they are giving to the developers or programmers with the current with the version by version. What are the concepts they are introducing in version by version? Yeah, we'll just discuss all those things. in
And
core Java,
okay.
in core Java and advanced Java. That's why that's why we have designed this course as around 90 to 100 days. So in that 40 to 45 days, we are focusing on only core Java concepts, because core Java is very important to learn any module. Even though, as I said, the same thing yesterday also, even though now we are talking about Hibernate, Spring Boot. Let us understand, after 3 years, one more new module will come into the picture, which reduces most of the code and
Runtime.
improves the flexibility to the programmer, in the sense a configuration mode. So
Okay.
if you go right, if you learn core concepts clearly, so whatever the core concept, same thing we are going to implement in Hibernate, Spring Boot. Even if you take, if you have a knowledge on Java or any Java EE, right, around 75 to 80% of the core Java we are using to build Java EE application only.
Enterprise edition.
Without core Java, you cannot run, you cannot learn, or you cannot implement any programming module.
Yeah, I
Like
was
Java
about to ask
EE,
about
yeah,
Spring Boot as well. So luckily we are going to know about the Spring Boot as well, right? Spring Boot.
yeah, Spring Boot.
Yeah. And the architecture, microservices, and the
Yeah.
makes sense. Yeah. Even I worked in another project on Java, but you know what, where I couldn't focus much, and I thought it was a bit tough for me to learn.
Okay. So
Before
what
I
is
get joined into another
what
job.
is the
And
modules you are using there?
we worked on the Java 8 and with the microservices architecture. That
Okay.
was with Spring Boot and the Kafka MQ. So these are the things that we have worked on actually.
Okay.
And I got to know recently there are some new concepts. I don't think it's a new one. There are some Java reactive concepts which has Flux, Mona, and all.
Okay. Yeah. Any other queries?
That's for me.
Okay.
Yeah. Thank you.
Okay, then that's up from my end. So we'll connect again tomorrow. Okay, with another topic, and we'll just continue. Thanks for joining today. Bye.
Thank you.
Thank you.